the right one. Yes.
Yeah.
Hello.
Yep.
Perfect.
Works. All right. is IoT and Sensors, and this is Cedric Cretas from the IoT Lab. I am Ulrike Falk from ECMWF. We are going to discuss today, as the title says, data spaces and IoT and sensors. So first presenter will be Cedric, then myself, and then we invited a guest speaker to talk about more on a project-based application of IoT. And so please, Cedric.
Hello? It's okay. My name is Cedric Reta. I am working for IoT Lab. We are a company based in Geneva. We are specialized in Internet of Things, so IoT, integration and interoperability of all kinds of sensors and whatever IoT. We are specialized also in IoT platform to provide data from sensors to IoT platform, and then the next steps will be to send the data to data space and to data spaces like the Green Deal data space, as we are building it in ID4GD typically. So the agenda of this presentation, we will talk about sensors, use cases, in particular for the ID4GD project, the communication protocols used in Internet of Things, a quick look also to OGC Sensor Things API, fireware, and also the term for IoT APIs. Basically, we have here the main categories of sensors. Basically, we have accelerometers, air quality sensors, biomedical sensors, which are very useful in the medical sector, of course, cameras, which are also sensors, chemical sensors, electric current sensors, which is also important to measure the consumption of energy, electrical energy, flow sensors, gyroscopes. We have also humidity sensors, level sensors, motion sensors, pressure sensors, proximity sensors, and of course temperature sensors. So we have here a lot of sensors which can be connected to the internet through the IoT. Basically, in ID4GD project, we have mainly two goals, two objectives in terms of measuring the environmental situation. Typically, we have four main categories of sensors: air quality sensors, the water quality, which is also measured, and of course, temperature and humidity. We have also a use case about biodiversity. We are using camera traps, which are in fact cameras with motion sensors to detect and take pictures of animals. Basically, we have the sensor now. We need to bring the data provided by the sensors to the internet. For this, we have what we call IoT communication protocols. Basically, we have two main categories of communication protocols: the wireless protocols and the wired or data protocols, which are more focused on the application level, in fact. Basically, in terms of wireless protocols, we have 4G, 5G, and also what we call NB-IoT, which is an evolution of 5G directly defined for IoT. And you have, of course, Bluetooth. You can find it typically on your smartphone. LoRaWAN, which is a well-known protocols with a long range. NFC, which is also the RFID, so also barcode also in this category. Sigfox, which is a proprietary protocols, which is well developed in Europe, Wi-Fi, of course. And you have also some protocols which are more focused on home automation originally, like Zigbee and Z-Wave. In terms of data protocols, wire protocol, we have several ones, typically AMQP, Advanced Message Queue Protocol, which is a classic one. And we have also CoAP, which is a protocol which was developed to replace some HTTPS for the IoT sensors and embedded systems. We have also a protocol which is the Data Distribution Service, DDS, which is also used. HTTPS, of course, and we have also MQTT, which was developed by IBM to monitor all transports, which is now largely used in IoT. And we have also OPC Unified Architecture, which is a protocol which is very used in smart grids also to provide information from different points. And we have also the extensible messaging and presence protocol. Basically, it's not a complete list of all the protocols, but you see we have different kinds of protocols to handle in IoT, so we need a lot of interoperability and integration between all different IoT in different systems using different protocols. So it is not an easy task to integrate all the IoT sensor into an IoT platform, and of course in the next step, which is the data spaces, as ID4JD we are doing for the Green Deal data space. An example of APIs, basically the APIs will serve from the communication part of the IoT to communicate to the platform or data spaces also. Basically, we have the first one is OGC Sensor Things API, which is an open standard. It is based on what we call a REST. Basically, a REST is a representational state transfer, which was defined by OASIS. It's kind of a standard which allow the communication in an open way for the data. It is currently the base of all the open APIs you can encounter. Basically, OGC is based on different application layer protocols, HTTP of course, but also MQTT, which was developed by IBM long time ago, and as mentioned previously, it is very, very used now in IoT. And we have JSON for the payload, and of course, we need also to manage the syntactic interoperability in this API. Basically, OGC Sensor Things APIs has two parts. One is a sensing version, which is linked directly to IoT. It allows to get all the data. By the data, I mean the observations and the metadata provided by the sensors. And we have also the part 2 of the Sensor Things API, which is the tasking core, which is used to set the different parameters in the IoT sensors or devices. Typically, if we have mobile devices, we need to configure some addresses. We can do it through this part of the Sensor Things API. Basically, the data model used by the Sensor Things API have two origins. One is an ISO standard, observations and measurements standard, which is well known, and also the sensor web enablement, which provide a part of the core of the OGC Sensor Things API. Here we can show the different part of the data model. So basically, at the center we have the data stream, which is the data itself with different parts in the data. The observation, which is a measurement, and we have also the part linked to the thing, which is a description of the physical equipment with the location and also the different properties. So basically, this data model is very useful for the integration of IoT sensor using this OGC Sensor Things API. Here we can go more in detail. So the data stream is a collection of observations. So basically, you get each period of time a measurement, and it is considered as a data stream when you have several observations. The feature of interest, it is the parameters you want to observe, typically the location or temperature or something else. The historical location is the history of all the previous locations. Basically, the last one is, of course, the most important. It's the current location of the device, and we have the location also. It is particularly useful for not in the case of mobile devices, but fixed equipment, typically. And the observation, which is in fact the measurement. We have also different other parts in the OGC sensor fixed data model, the observed property, which is kind of metadata in the sense you have the name, the definition, and the description of a measurement, which allow us to have more information on what we are measuring. Typically, if you are measuring the wind, we have the velocity and the direction. Sensor, it is a physical sensor itself. And thing is a virtual object or physical object, which includes the sensor. I have put here in this slide some useful links. So we have the standards for the sensor things API and also the GitHub. We have also in IoT Fireware, which is the most well-known open source platform in Europe. So basically, Fireware is an open source framework in the sense we can build a smart application on top of it, in particular IoT platforms. Whereas there are different main domains, so smart agri-food, smart cities, smart energy, smart industry, smart water. So we can collect a lot of data. We have a lot of data models in Fireware. Basically, there is two standards, open standards existing. The old one, which is NGSC version 2. And now we have a new version, which is NGSC LD, which use linked data. The standardization in Fireware was made originally by Open Mobile Alliance, although it was used at the beginning by several telecom operators, and then when the NGSC-LD version appears several years ago, it was made by HC. So HC take the lead in the standardization, and we have the current version was published in August last year. Basically, the meta model of NGSC-LD is relatively simple in the sense it is based on JSON-LD, so we can use linked data directly in the data model. And we have 5 concepts. The first one is an entity, which is the representation of a real object. Each entity has some properties, which is an attribute of the entity, and we have the relationship between each concepts, which is the part linked also to the linked data, and we have a type which is which can be defined by the users. There is also some class defined by the web ontology language, which can be used also, and the value is a JSON or a JSON-LD value. What is interesting in Fireware is we have a lot of partners, entities contributing to what we call smart data models. Basically, it's a website which is not only collecting all existing smart data models, but also creating new ones in function of use cases. So I have put here the statistics from the beginning of this month. So you see we have quite a lot of data model, almost 1,000, and we have almost 300 contribution, and you can see we have a lot of companies using it or project with 281, which is difficult to measure exactly because it is an open source framework with all the data models, which are also open source. So it's only an indicative value, but it is very well used in Europe in the different domains linked to IoT. Here I have a short example of smart data models. You see it's, we have two representations. The basic one, which is like this. On the left, you have the key, which is the attribute, and then you have the value. Typically, you have the measurement of the water quality. So we can see here typically the conductivity and different elements like the temperature and pH. And you have also a second version, which is the normalized version. For each attribute, in fact, we give a mandatory type and value, so it permits to know a little more about the metadata, typically the value. For example, we are defining a specific type, notably for the location, using geoproperty, which are more complex. Furthermore, we have different components which are called by FireWire generic enablers. We have the main components is a context broker, which provide, in fact, the different interfaces through the NGSC API. So currently we are in the version NGSCLD, and then the context broker forwards the data to different databases like STH-Comet and Quantum Leap, which is currently based on CrackDB or Timescale DB, and you have you can create a complete historic of data. You can store all the historical data in this database. And we have also some other component supporting big data or data routing. So it allows the management of big data, but also to have complex data flow. So I mentioned here Cygnus and Draco, and also for the big data Cosmos. Basically, all these components are based on Apache. And we have also different other components which can be used when you are building a complete IoT platform based on FireWire. So we have IDAS, which is a kind of agents to connect with IoT devices, also robots. And we can manage also different graphical user interface and the content. Typically, Currento is managing the media streams, and you have also WireCloud, which is a web platform which permits to create dashboards, customized dashboard, in fact. And we have also different components like Kirok and Vilma for the identity management, so the management of the user, including the authorization and the authentication. And we have also some extension for CCAN. CCAN is an open data server, and we can use this extension to push automatically from a FireWire platform the data. And we have also the BIS framework, which is a set of APIs from TM Forum, which allows the monetization of the services of FireWire. And here I have put different links, notably the official website of FireWire, the marketplace, and the list of components. Finally, in terms of actors present, not only in IoT, but more general in the communications world, we have a TM Forum. Basically, TM Forum is a global association with a lot of industries. We have 850 members currently. Basically, the members of this alliance, this association, are the telephone companies, the classical cable and network operators, but also now we have the cloud providers and communications service providers. So it means we have a lot of actors doing digitization, digital transformation, and they are very interesting also to collect IoT data for the different use cases. And the main objective of this association is to ease the digital transformation in the telecommunication industry, which include also other partners using the networks, like customers collecting a lot of data, including IoT data, environmental data. And then TM Forum has developed one initiative which is called TM Forum Open APIs, which is a different sets of APIs. Why TM Forum developed these APIs? It was to facilitate the management of the services by different actors and stakeholders which are connecting together. So we need so to realize this, we need interoperability, of course, and also the portability across the different services distributed among several stakeholders. And originally, this Open APIs was developed for typical applications and use cases in the telecom sector. So, all the activities linked to the management of the infrastructure of a telecom operator, what we call operations support systems, but also the part which is displayed to the customers, those business support systems. What it is interesting for TM Forum, we have a lot of open APIs, 60 currently, and we have a million downloads, and you can see also there is a lot of software developer using it. Here I have given an indicative number currently available. So 32,000 software developers for 2,100 organizations. What it is interesting in the context of TM Forum, we have developed also two APIs dedicated for IoT. The TMF 908, which is the IoT Agent and Device API Component Suite, and also the TMF 914 IoT Service Management API Component Suite. These APIs are generated automatically from source by Swagger tools, and we can extend easily these APIs to whatever use case, adding more parameters, attributes if needed. The data models are defined by the TM Forum community, but what it is also interesting, we are aligned with FireWare and GSC, notably by the use of payload in JSON, which are very similar. And I will give you a quick look on the TMF IoT Agent and Device API. You can see we have a lot of features which allow the management of all the devices and agents, like we are doing in OGC Sensor Things API. Here, an example of payload from the IoT Agent and Device API. We have on top of this API the IoT Service Management API, which is a dedicated IoT service. So it allows the remote management of the IoT devices. It is made to increase the scalability and the interoperability, and also the monetization at the end of the day. And here, an example of a payload from JSON based on the service category object. I have put here different link to TM Forum if you are interested. And I will also mention the website of ID4GD and the different social media if you're interested to participate and to discuss with us about the Green Deal data space, in particular for the IoT data. Thank you very much.
Thank you, Cedric, for the very comprehensive presentation. Are there any questions? I mean, we will allow some discussion afterwards, but maybe you want to have some questions to the presenter right now, to Cedric? Yes.
Yeah, one question regarding the standards. We all know that NGIS is one standard or one potential standard in data spaces. What about the other ones, GaiaX, IDSA? How do you see the evolution of those standards? Which standard will win eventually?
Good question. I think
I have a theory, actually.
Yeah, I'll let you.
Please.
Please. Yeah. I think currently there is no real winner. There are several protocols, in particular in IoT. You see, we have a long list. We have several levels of protocols. We have on the sensor, but also now on the.
Oh, I was more looking for the data space protocols, yeah. Like NGIS, not the IoT protocols.
Yeah. But I think it is also linked because if you look to what we need to achieve to a data space, we have also some constraint which should be handled also by the IoT part also. In the sense we need to answer we have something which is scalable, interoperable, and the top protocols used by the data spaces should have the same requirements.
Some more question? Please, take the microphone, Victoria, so the online guests can also.
Yes, I just wonder how all these different standards and tools, is there a map of how these connect, or are they completely disconnected? Because we have OGC, sensor things API, then we have all of these other tools. So if someone is trying to use a protocol, what do they choose?
Basically, we need to map the current utilization of these IoT protocols to the protocols used by the data spaces. In fact, to define a set of protocols to be supported by the data spaces, and otherwise to have some proxy, intermediate proxy, which convert once from the data from one protocol to another one. What we are doing also in our package 3 of ID4GD.
May I add something? Because there is a standard involving here. If you don't know anything about the devices, MQTT is going to win the race. There's the Eclipse Foundation has run 2 surveys, which is the most common IoT protocol, and MQTT was the winner 2021 and 2023. There is a lot of REST APIs already out there. Of course, the sensors, many sensors can speak REST, but that's more of every IoT platform has a REST interface, so let's have the IoT gateway look for that. So as an application, so on the right side of your protocol, if I don't know anything about your specific use case, use MQTT. If that doesn't work, you have to go to somewhere else. And the second question is what transmission protocol you want to use. And that depends on the sensor. If you have a water sensor, which is sending 1 measurement per day of the water temperature, you can't use any complex, protocol. You use narrowband IoT, lightweight M2M. So it depends on the sensor and the environment. What type of sensor do you get? But then you have another box, the IoT gateway or something like that, and after that you send MQTT to whatever platform. That's, if I don't know anything about it, I would recommend that. And then it starts where exactly. Cedric has said, okay, you have to map that here.
Exactly, MQTT is one of the most used.
And for the data spaces, I'm owing you the theory of mine. You will have many different data spaces, and they will have different protocols. I don't think that the Data Space Business Alliance will converge on Fiverr versus IDSA versus other standards. So you will have sector with different data space protocols. But in order to make them interoperable, so that you can be in one member of one data space and the other, that's most probably being one of the Gaia X standards. That's State of the Nation 2022, the November Gaia X Summit, I think. But the guys at the Data Space Business Alliance have to agree on that, and they are behind schedule, I would say, in that discussion.
Yeah, I will also mention Fiverr is very involved in IDSA historically, so partners also.
Yeah. But
any questions?
So you mentioned MQTT is most popular at the moment. Do you know about OPC UA? I know industry is pushing forwards.
Yeah, that will win in the industrial space. If you go to a factory, it's OPC UA. All the new standards will have that. Yeah. The problem is that you have production machines which will be operational for yet another 40 years. So it will take two generations until every production machine, Werkzeugmaschine, whatever mechanical engineering thing. But the new stuff all speaks OPC UA. Yeah.
Maybe it would be a good idea if you say something to mention your name and where you come from.
Yeah,
so
Christoph Strenadl, Software AG. I'm the deputy CTO, so we provide kind of what IoT Lab does on one level, we provide also on another level, like IoT platforms for like 1 million elevators or so, or 10 million.
My name is Florian Jasche. I'm from Fraunhofer, FIT, Applied Information Technology, and I'm also working here on the project 84GD. And we do human-centered design at our department, but I'm especially working in a subgroup about IoT prototyping, and we have a lot of contact to industry, especially production and manufacturing, and OPC UA is all over the place, and yeah, of course, also MQTT.
Victoria Lash, I'm from Aston University. I also work on all data for Green Deal, and I'm specifically looking, well, at this stage, into citizen science data, which is related to IoT. So collecting citizen science data using local sensors and also semantic interoperability. I know nothing about sensors. That's why these questions come from.
So are there any further questions to Cedric?
Thank you very much.
Thank you very much. Just give me a minute time. We didn't have time. So my name is Ulrike Falk. I'm from the ECMWF. That's the European Center for Medium Range Weather Forecast. And we also work on IoT data infrastructure, and I'm going to present our future plans and the strategy for ECMWF's IoT and unconventional observations work. So first, to introduce you a little bit to the ECMWF, I'm not sure if everybody of you is aware. It's established in 1975, and it's an intergovernmental organization with 23 member states, 12 cooperating states, and we currently have 550 plus staff. We are actually growing. Recently, we went from a one-site organization to a multi-site organization, which is based in Reading, the headquarters, and Bonn is the main location for the staff, and Bologna hosts the HPC and the other system. We are a 24/7 operational service, operational numerical weather forecast, on high resolution and ensemble forecasts per day, and also research institutions. That means we experiment and to continuously improve the model and on reforecasts and climate reanalysis. We also operate 2 European Union Copernicus services that is providing data free of charge to the community. That is the climate change service, the 3S, and the atmosphere monitoring service, CAMS. We also support the Copernicus Emergency Management Service, SEMS. Destination Earth is the biggest project that we are currently running as a research project, and that includes the operation of digital twin engines, and we are operating 2 digital twins. So to go into ECMWF's operational production workflow, you can see here that there is something going on. And we're back. Good. So as you can see here, yes, you can see my mouse. Very nice. So we get every day, we get a ton of information from global observations that is being acquired into the ECMWF ecosystem to be fed into the Earth system model, and but also stored as observations into a perpetual archive. This Earth system model produces fields of different geophysical and other variables that are then also introduced into the archive. And at the end of the line, the product dissemination is going back to the member states and other licensed users. These products you can see here are fields of data that, just to give you an idea of the amount, the quantity of data that we're dealing with, it's global observations. We're ingesting every day 200 million observations. So these observations are then being used for the Earth system model, but that they're being selected by the highest impact, and that is means only 10% of this data are being used actually to run the model. In total, we have to deal with 300 terabytes per day. And as a product, what goes into the product dissemination is about 45 terabytes per day. These products are then fed into about 350 world destinations. So here you can see only 10% of the observations are being used, and as I already told you, selected by the highest import. The operational data pathway in the ECMWF's operation ecosystem is quite complex. I'm going to focus here on the operational data pathway, which means the observations that are being fed every day into our ecosystem and are being acquired by a service that we call ECPDS. That is then being analyzed by this box that is called SAP. It's the Scalable Acquisition and Pre-Processing System that is then dealing with the quality assessment, but also with the standardization and the several operational steps that are important to run the IFS. That's the numerical weather forecast system that we have, the integrated forecast system. Here you can see that is the observation database, so that there are 2 paths here. One is being ingested into the IFS as a buffer in a buffer format that is a WMO standard, into the IFS. And I would like to focus on this operational data pathway. We are very much interested of acquiring more and new observations, and that is why our interests lie in the IoT observations and unconventional observations that are not being obtained by meteorological services or other other organizations that are using these standards. So the availability of the challenges for the use of IoT observations now is for us is the availability of up-to-date metadata, but also including unique identifiers. We have reporting standards, and those are important with respect to the stability of the coding practices. And for this, we also need a certain data governance that is to standards and licensing frameworks that define and promote standards. The delivery mechanisms for the application of IoT or for the use of IoT observations, we see several issues here. That is, one is the stability and the reliability of the sensors and the reliability of the data streams from these IoT observations. Another question is, since we work a lot near real time, is it possible with for the use of IoT observations? So there are different questions that we need to investigate to find some answers in order to check the possibility of use for IoT observations. The diversity of sources can also be very changing for individual organizations, and thus it also leads to the question of cost efficiency. This is for us it seems more cost effective if it's managed only by a central organization and then being fed back into the community. So another one is also the quality control is very challenging. You have error structures that are very complex, or sometimes even most of the time not known. There's inaccurate or changing metadata of the sensors. There's a dependency on weather patterns and many other unknowns, such as sensor changes or location or the mobility of the sensors, amongst very many others. So we see a need for novel quality control methods, and then the question would be if machine learning-based approaches should be investigated here, which we find seem to be very promising. There's a large density of data that allows, for instance, for body checks. If you have a dense network of different observations, you can always check for outliers by comparing the nearest neighbors. And also, how do we correct for errors in IoT observations, correct for systematic or random errors? And most of all, and I will come back to that in a later issue, in a later slide, it's the privacy settings. That means the identification of the data is very important. But how do we save the individuals? I mean, a lot of personal weather stations, they are being run by households, so that would give the location of the people that are running these and that might indicate, of course, where they live and how maybe some other information that is not supposed to be shared online. It is also impossible to characterize the data without properly identifying the data, and perform a proper data selection. So these are the challenges that we see in the use of IoT observations. For data infrastructure ideas, this is how we see how we want to make use of unconventional observations or IoT within our system is we want to feed in from different sensors around the globe, and we want to expand our service ECPDS to also acquire those observations. That means there's a need for proper identification, decoding, quality assessment, filtering, aggregation, and labeling of the data before we encode it and put it into an observation store. And here are several ideas that we have on the of the use of these data from this observation store, and that is monitoring, of course, the verification of other data, diagnostics of certain state. Since we're dealing with mostly meteorological data, it's diagnostics of the state of the atmosphere or the environmental system, archival and post-processing. And maybe as a future plan, how might be the data assimilation for the use in numerical weather forecast. So we are currently working on a data infrastructure that is also flexible but also scalable and data-driven in order to adjust to the needs of the IoT data. So what we see as community approaches to IoT data is, of course, there needs to be a certain standardization of the different services and protocols. That means develop and promote common standards and processes and build common frameworks. We see high value in shared tooling. That means pre-processing, filtering, checking, data encoding, data decoding is that's based. That is important to be shared also with the community. So in order also to get enough feedback on the quality. Then community data hubs. There's a lot of heavy work if you work with IoT data, and it's important to avoid that everybody is doing the same work and inventing the wheel at the same time. So it is important also to facilitate the data sharing and to acquire pre-processing, basic QC, quality control, and format standardization. So the challenge is that IoT data are diverse in every aspect. And this is being done from our side. We do this in third-party projects as pilot projects, and to set up the necessary data infrastructure as kind of an experimental field, a research field, so that we can then learn from the work and at some point see how we go from there. So one of the projects that we're working on is iChange, that is citizen actions on climate change and environment. The main objective is to collect environmental and socio-economic data from living laboratories that use sensors and monitoring devices, simplified models and unconventional data sources to provide user-friendly tools for user communities to users and communities to use the data. Our role is here to build the infrastructure for ingestion, quality assessment of IoT data and of the novel observations, and make project-specific processed observations available to other partners through the infrastructure. The second project that we're currently working on is on the combination of climate and health, and the data infrastructure is what we call the Climate Health Connection Hub. It is to identify and monitor and quantify direct and indirect impacts of climate change-induced environmental hazards to health. This is being done by collecting and combining weather climate, the observations and health data collected in the Climate Health Connection Labs. This is how we call them on this site, where with provided tools and structures, with provided wearables and sensors that are also being developed within the project. The hub is meant to collect and combine weather climate data with socio-economic and clinical health data. And here, as you can see, it comes into play what I talked before about the privacy settings, because of course the privacy settings of health data are pretty restrictive. Our role here is to build the infrastructure for ingestion, quality assessment as well, of the respective IoT data and also of the observations that are being obtained within the project. And to make project-specific process observations available to other partners through the infrastructure. At the end of this project, there's supposed to be an infrastructure that is then providing also climate health indices or climate tools for early warning systems for health risks based on direct and indirect impacts of climate change induced environmental hazards. And we're also involved in AD4GD, All Data for Green Deal, and which has, but I'm sure you have already heard about it today. It's to co-create and shape the European Green Deal data space, which is an open hub for fair data, which is findable, accessible, interoperable, and reusable, and a hub for standards-based services. And my colleague Cedric already talked a lot about the respective standards and protocols. Our role here is to connect new observation sources to our CAMS system, the Copernicus Atmospheric Monitoring Service, and ground truthing and data trustworthiness framework, which is from our team not IoT data, but So, my takeaway messages, or our takeaway messages today here are that, of course, if you regard IoT data as high frequency and low volume, but of high value as we see it, contrary to forecast data, for instance, observations do not lose in value over time, whereas if you look at a weather forecast in 3 days' time, it's not really it's not really as much worth as it would be on the actual day. IoT data are diverse in every aspect and generally not calibrated or uncurated. The handling of IoT data requires community-developed tools to pre-process and pre-check the IoT data. And in order for us, it's important to capitalize on the deliverables from funded projects to define and promote standards back to the community. Promote data, but also to promote data and share experiences from our work. And this also includes the metadata and unique identifiers of IoT data. The challenges are here to define ways to use the data without compromising the privacy settings or the privacy of the data, and find new paths to properly assess the data quality and the respective uncertainties. And with this, I would just like to make you aware of an upcoming workshop that is being carried out within the eScience conference at the beginning of October. We call it Instill, which is citizen science engagement on ICT solutions. Well, and thank you very much. Do you have any questions?
What is the timeline for your other 2 projects? So not the AD4GD. I mean, what is the duration? When do you think you're going to get deliverables done? When did it start? When it's going to end?
Yes. Okay. The iChange project, that is socio-economic data ingestion into the work on the data infrastructure on socio-economic and climate connection, that is already within, it's already being running since 1.5 years. And we are pretty much halfway through. We now have the internal review, which means that that there's it's going to have, we're pretty much halfway. The trigger project has started about a year ago, so we just had our annual birthday, first year, and there we are currently assessing the needs of the users and the requirements of the health data. That is something that we are, as a geophysical or meteorological service, we are not very familiar with. So we are currently just in the starting phase of, we're currently defining the architecture of the data infrastructure, and then we will start working, we will start setting up the respective services. More or less what we do is that we use what is already available within ECMWF. We have a great number of services already available, that is, and we are very familiar with handling great amount of data. So the question is, how do we treat the data so that we can ingest it into our system? And that is something that we are within Trigger, we still have to define this.
And in terms of deliverables, are they going to be internal or publicly available? So what is the, how is it managed in terms of public access?
Yes. So all three projects are EU or EC funded. So it's the main goal is to have most of the deliverables will be openly available. There are, of course, certain parts of the data infrastructure of the data that we cannot share, because of course health data carries, it does not allow for sharing. But what we intend to do within the project, and that is not part of ECMWF specifically, but of the greater project, is that we provide early warning tools to the user community, so that and indices that are combining health and as I said, risks for the health, citizens' health, or for climate-induced risks like extreme temperatures, flooding, or these kind of things. Yes.
Thank you.
Yes.
So you mentioned you have around 2 million observations per day in the beginning. What do you count as observation? What is an observation you are talking about here?
These are what we count as observations, since we are dealing with a weather forecast. It's of course meteorological observations, that is from satellite, but also from in situ observations like buoys or any other, or LiDARs, for instance. So there's a great variety there of different sources of data, meteorological data. That is the expertise, and that is the focus of ECMWF.
Thanks.
Any more questions? All right, so I would like to invite our third speaker. He is online. It's Antonio Parodi. Do we know if Antonio is already online?
Unfortunately, Mr. Parodi will not be attending the event due to time restrictions.
He's not able to.
He's online at the moment, so can't be.
No, but he would give his presentation online, is it not?
I don't know if he's giving it later, like a video, but he can't be live here virtually.
All right, that's a pity. I thought this would be a hybrid session. Okay, so then I think we have some time for more discussion. So please feel free to ask anything about the presentations.
I have a question on on slide 11, you mentioned in the middle very prominently the semantic interoperability space. 11, I think it's the next one. Yeah, semantic, can you tell a little bit what that is?
Do you want to answer this, okay?
Because it looks like solving every problem.
Yeah, basically what we try to achieve is to use in ID4GD's environmental variables and also the semantic interoperability.
Yeah, but what is that? Can you give me more examples concretely what you mean by semantic interoperability space? Or is that a mapping service, or is there a human translating from one model to the other?
Yes, exactly. Basically, we have, as you see in the left, we have different heterogeneous sources of data. So we have satellite data, you have Internet of Things, citizen science data, statistical data, in situ networks. Basically, at the end of the day, we have a large amount of data, but the big problems were something which are not interoperable by design. And we need to use semantic interoperability to solve this problem.
So you would, in that space, it's not really a space, it's a function. So you map the different things.
Yeah, it will,
okay.
It will be part of the tasks, the activities of the data space. Yes.
So it's not it is on the left side we have all these different models and statistical data or networks, but on the other side we have the data applications, and these are 3 pilot projects that AD4GD is running on. One pilot that is exploring or acquiring data on climate change, on zero pollution, and on biodiversity, and we are doing the mapping of the different.
I totally understand the pattern. I was kind of not confused by the space, the term space. Normally you would have an interoperability layer or something. It has nothing like a space, or does it? That is what I wonder. Normally you have this is in enterprises, we have been doing that for 20 years. It's called enterprise application integration, enterprise service bus. You have that kind of stuff which has been done for millions of data sources all over the world. So I was wondering whether your space is beyond that pattern. That would be interesting. If it's the same pattern, like you have machines and programs which take the data and convert it to another program, then this is a well-understood problem, which is hard, but nevertheless we can solve it. But maybe it's more than that.
It is a bit more than that, but I'm sorry. It is definitely more than that. Yeah. Yes, definitely. But as you can see here, our circles are on the left and the right side of the data space. So these are other project partners that are working on it, and you will definitely hear some more on. Or maybe you did see the talk by Jean Massou this morning. I'm sure he talked about these data spaces.
Yes, but we will discuss of semantic interoperability, I think, in the coming days also. Yeah, a dedicated day for this. Any other questions, discussions, comments? Well,
then I think we can go for a coffee.
Yes.
Right?
Thank you very much. And, see you in the coming session also in the coming days.